students, welcome to another video where we will be discussing measurement. So if you are studying for an exam, paper 2, grade 9, this is the video to watch if you want to cover the section on measurement. So remember, for paper 2, we always have 3 main topics, which is measurement, we've got data handling as well as geometry. So this would be the second video of the 3, which I will be doing on measurement. Okay, so what I've done is throughout my teaching, I have taken the past papers and I've selected all the questions on measurement and I threw them into one PDF and I will be working through them with you. So the best way to study is just by doing past papers. So that's why I find it very, good to go through past exam paper questions before an exam, just to get your head into the types of questions that you could be asked. And if you are lucky, sometimes you get exactly the same question or same type of question. Okay, so let's look. Question 1. In the diagram below, ABCD is a square. So very important. We know that all sides are equal. And the area of a square is side times side. So the area of a square is side squared or side times side. And let's just read a little bit further. And AOD is the diameter of the circle. AOD is the diameter of the circle given there. Calculate the area of the shaded section. I wrote there in terms of pi, but I don't know why, so I took that out. If the radius is 7. So do you agree if the radius is 7, the diameter will be 14, 7 plus 7, which makes each side of the square 14 centimeters. I hope you could see that. So the area of the square is going to be 14 times 14. And then we want to subtract the area of half a circle. Okay, it's only half a circle. So if you've got the area of the square, we're going to have all that. And then we want to subtract that half a circle over there. And we will be left with the shaded area. I hope that makes sense. Okay, and the area of a circle is pi radius squared, and because it's half a circle, I'm going to divide it by 2. And we know now that the radius, I'm going to replace it with a 7, and then this will give me 196 minus 76.969, and if you subtract that, I'm locking it in as my answer and say 196 minus that gives you 119.03098. And normally with the IB exams, they ask you to round off to the nearest 1 decimal place, which will then just make this answer 119 centimeters squared. Okay, not too bad. Then, number B. So these are the harder type questions. I forget about all the easy type questions. I haven't copied them. These are the more difficult ones. So if you want to challenge yourself, so please have a look. So you might look at this whole video and say, yo, this is very hard. It's all section B type questions. Okay. All right. A nursery school sandpit is in the shape of a rectangle with the length 1 meter longer than the breadth. So can you see if this one is X, in terms of X, this one will be X plus 1. I hope that makes sense. The school would like to enlarge the sandpit by adding 2 meters to the length. Okay, so the length 1 meter longer than the breadth. So over here it was X plus 1. And now they want to enlarge it by increasing or adding 2 meters to the length. So plus 2 and to the length and 3 meters to the breadth. So X plus 3. Determine the increase in area of the sandpit in terms of X. Okay, the increase. So the increase in terms of X. So we're not going to find an answer. We're still going to have X in our answer, but that's okay. You're going to get a lot of these questions going forward in terms of X, or calculate the following in terms of Y. Okay, so you better just get used to it. All right, so for the smaller sandpit, what would be the area of the smaller sandpit? Can you see that it would be X times X plus 1, which gives you X squared plus X. Then the bigger or the enlarged sandpit is, if you simplify that, it's X plus 3, and over here is also X plus 3. So X plus 3 times X plus 3 You FOIL it out. X squared plus 3x is plus 6x plus 9. So now determine the increase in the sandpit in terms of x. So we need to take the bigger sandpit and we're going to subtract the area of that from the area of the smallest sandpit. So remember, whenever you're subtracting more than one term, you have to put brackets so that that negative goes to both terms inside the bracket. So this will give you x squared plus 6x plus 9 minus x squared minus x. And then your answer is going to be, sorry, I'm going to write it here on top. X squared minus x squared falls away. 6x minus 5x gives you 5x plus 9. So there is your answer of the increase in terms of x. Okay, so hopefully you might have looked at it and say, well, how do you get this? But after doing the picture and the algebra, and the more you do these sums, the easier it will get, I promise you. Okay, in the diagram below is an isosceles triangle ABC with BC is equal to 13 centimeters and BF is 5 centimeters. So immediately you must think, Pythagoras, then I'll get the radius of that circle there, which will be the same length there. Okay, so square ACDE has an enclosed circle touching all four sides of the circle. So it means that it just goes exactly onto the perimeter there, or the circumference of a circle, and it is a square, very important. Calculate the shaded area of the diagram to correct to 2 decimal places. Okay, so I'm going to highlight there for you so that you don't forget. Now, if you look at this triangle, we have the height, which is 5, and we've got the slanting side 13. But we don't have that base over there. Okay, because we need that, because the area of a triangle is base times height divided by 2. So what I'm going to do is I'm going to just use half of the triangle so that I've got a 90-degree triangle, so that I can use Pythagoras to work out the base over here. Okay, so I always say zoom in, use the 90-degree triangle, and then zoom out again. Remember, what you are actually doing is you're working out the area of the full triangle. Okay, so it's going to be for the base, let's do that like this, for the base of the triangle. I always like to write it nicely so that I can see what I'm doing. I'm going to write it out. So it's b squared plus 5 squared is equal to 13 squared, which is because of Pythagoras. And if you take 13 squared and you subtract 5 squared, you get 144. And the square root of 144 gives you plus minus 12. But because it's a distance, it will be a positive 12. So we know that from there to there is 12. Okay, but now I just use that to get the base. Now I know, because it's an isosceles triangle, I know that both sides are going to be the same. So AF over there is also going to be 12. Okay, so next step, I'm going to work out the area of the triangle, which is base times height divided by 2. Lots of you would have used the base as 12, but people, it's not 12, it is 24 times 5 divided by 2. And 24 times 5 divided by 2 gives you 60 centimeters squared. Is that all shaded? Yes, so I'm going to include that in my final answer. Now let's look at the last one. Okay, so this part, how do we get the shaded area here? We're going to work out the area of the whole square, and then we're going to subtract the area of the circle, and it's going to leave me with that shaded area part there. Okay, so the area of the square minus the area of the circle, and the circle is a full circle. I don't have to divide it or anything. So the square is going to be 24 times 24 minus the area of a circle is pi 12 squared. Can you see from there to there? The radius will also be 12 because it's the same measurement as that. 24 times 24 gives you 576. And if you subtract pi times 12 squared, it gives you 452,39. I'm going to lock it in as my answer, and then in front I'm going to put 576 minus. So the area of those little corners all add up to 123.61. And that is the other part of my shaded area. So the total shaded area gives you 60 centimeters squared plus 123.61 centimeters squared, and all together it gives you 183.61 centimeters squared. Okay, I hope you also got that. Are you okay with these? There's always triangles in your shape, so please learn your area and your mostly your area for the triangle and the circle, and the rest are quite easy. All right, let's look at this question. The dimensions of the Olympic swimming pool are shown in the following diagram. The depth of the pool is the same all throughout, so it means there's no shallow end, it's just deep all throughout. The total capacity of the Olympic pool is 2.5 million liters, and calculate the volume of the pool if 1 liter is 0.001 meters cubed. Give your answer in meters cubed. Okay, so because they talk about meters cubed, can you see this little bugger over there is given to you in centimeters? So 25 centimeters, if you divide that to get it into meters, how many centimeters in a meter? There's 100 centimeters in a meter. So I'm going to divide with 100, which gives you 0.25 meters. Okay, so now they say to you the total capacity of the Olympic pool is 2.5 million liters. Calculate the volume of the pool if 1 liter is 0.001 meters cubed. So they tell you 1 liter is 0.001 meters cubed, but we don't want 1 liter. We've got 2500123 liters. 2500123. Okay, so we're going to divide up and times down to get the volume of this pool. And that gives you, if you take 2.5 million divided by 1 times 0.001, it gives you 2,500 meters cubed. Then it says to you calculate the depth of the Olympic pool. Write your answer in meters. Okay, so remember the depth we have now the volume, which is length times breadth times height. Okay, the length is 50 meters times 0.25 that I've already worked out there, times the depth will give you 2,500. So thus the depth will be 2,500 divided by 50 divided by 0.25, which gives you 200. Sure, can it be? Let me just do that again. 2,500 divided by 50 divided by 0.25, which gives you 200 meters. Okay, question 3. The dimensions of the Olympic swimming pool are shown in the following diagram. The depth of the pool is the same all throughout. So there's no shallow end, there's no deeper end, it's just all the same length. the depth, sorry. So the total capacity of the Olympic pool is 2.5 million liters. Calculate the volume of the pool if 1 liter is equal to 0.001 meters cubed. And it then says, give your answer in meters cubed. Okay, so we're going to write down, if you know the pirate method, 1 liter is equal to 0.001 meters cubed. And we don't have 1 liters. This pool is the size of an Olympic size swimming pool. So it's got lots of liters. And if you know the pirate method, you write down what you have, write down what you want, and then divide up times down. So you take that answer, you divide up times down, and you've got 2,500 meters cubed. Then it says to you, calculate the depth of the pool, write down the answer in meters. So the volume for a rectangular base prism is length times breadth times height. And the height in this case would be the same as the depth. And that gives you an answer of 2,500 meters cubed. Now, I made a mistake. So if you got down the PDF or you downloaded the PDF, it shouldn't be centimeters. They both should be meters. Otherwise, it's going to make it a very strange pool that it's less than, you won't even fit into it if it was 25 centimeters. Okay, so it's 25 meters by 50 meters. So 25 meters times 50 meters times what will give you 2,500 meters cubed. So then you take that 2,500, you divide it by 25, you divide it by 50. So the height gives you 2 meters, which is a nice answer, and it makes sense. If you got like a ridiculous answer of 20 meters, just think of it in real life. Would there be a pool that is 20 meters deep, same as 0.2 meters? Then you won't even be able to dive in, but 2 meters makes sense. Okay. Then they say to you, the space around the pool is paved. The paved area of the swimming pool has a width of 2.5 meters. Calculate the area of the paving in meters squared. Okay, so if this is 25, then we need to add 2.5 and 2.5 on each side. And if this is 50, then I'm going to add 2.5 and 2.5. So it's going to be the area of brick and pool minus the area of the pool only, which will give you the area of the paving. I hope that makes sense. So it's the area of the pool and the bricks. So if I had to color it, it's everything minus the area of the swimming pool will leave you that pink area of the paving. Okay, so it's the area of the brick and pool minus the area of the pool. So now for the brick and the pool, if this is 25, I need to add 2.5 and 2.5 to that, which will give you 30 meters. And you times that with the pool, which is 50, plus 2.5 plus 2.5, which gives you 55 meters. Then I want to subtract just the area of the pool, which is easy, 50 times 25. And if you put that into your calculator, you should get a beautiful answer of 400 meters squared. Okay, here's another question in terms of X. It says Gareth's tiny room is a mere X meters in length and 3 meters in width. So we don't know the length, we don't know, or the width we know is 3 meters. And the length we know as X meters. And this is Gareth's tiny room. He decides to do some renovations. He extends the length of the room. So this would be the bigger room now. He decides to extend the length of the room by 4 meters. So this one was x meters in length, so now the x will be extended by another 4 meters, so we'll plus 4 meters. And then it says, if the area of the new larger room is doubled the area of the original room, calculate the length of the new room. So basically, calculate the length of the new room, which would be this. So if we can find x, we just need to add 4 to it to get to our final answer. So I hope that makes sense. So please take pictures or try and use pictures to depict or to show what you are busy working out. And yeah, hopefully that helps. So I'm just going to go through it again. Gareth's tiny room is x meters in length and 3 meters in width. Now extends the length of the room by 4 meters. So we add 4 meters. And if the area of the new larger room is double the area of the original. So remember, the smaller room must be 2 times the smaller room will give you the larger room. All right, so the area of the small room, or the original, is 3 times x, which gives you 3x. Then the area of the larger room, sorry, I did the colors now the wrong way around. I like to always be consistent. The area of the larger room is, so all he did, this one is still 3 meters, because all he did, he extended the length with 4 meters. Okay, so now the area of the larger room would be 3 times x plus 4, which gives you 3x plus 12. So now they say to you, remember, the area of the small is twice the size as the area of the larger room. So we're going to find x with the help of an equation. So I'm just going to bring it down a bit. And 2 times 3x is 6x is equal to 3x plus 12. So 6x minus 3x is 12. And then you get x is 4 meters. So now we just want to go test this and see whether it does make sense. So the tiny room, the smaller room, the original room, was 3 by 4, if x is 4. Then the area of the larger room was 3 by 4 plus 4, which gives you 8. So now if I look at the area, 4 times 3 is 12 centimeters, sorry, not centimeters, it's not a baby person, 12 meters squared, and the area of this bigger, larger room, 8 times 3 is 24 meters squared. Is it double? Yes, it is. So well done, you got x right. So always go test yourself, say, does it make sense? You know, if I go plug it back in, does it give me what they were, you know, all the specifics they were talking about? So now the final question, or the final answer, sorry, was calculate the length of the new room. So the length of the new room is equal to 8. 4 plus 4 is 8 meters. And then just always highlight or let your answer stand out, especially if you've got lots of things going on all over the place. Okay. Now, another Lekker level 4 type question. It says the length of a rectangle is 3x plus 2. So let's draw a rectangle. The length of the rectangle is 3x plus 2, and the width is 2x minus 1. Determine the perimeter and the area in terms of x in its simplest form. Okay. Not to worry, we're not scared of these questions anymore. The perimeter and the area all in terms of x. Okay, the area is length times the breadth, which gives you 6x squared minus 3x plus 4x minus 2, which gives you 6x squared plus x minus 2. So there's your answer. There's the area in terms of x. And now the perimeter in terms of x you can just go ahead and add them all together. 3x plus 2, you can times it by 2 if you want, and then 2 times 2x minus 1. Perhaps that's easier. Or otherwise, you could have said 3x plus 2 plus 2x minus 1 plus 3x plus 2 plus 2x minus 1. Okay, remember when you add, it doesn't really affect your, or it doesn't affect your signs, so you don't have to stress about that. It's only when you subtract where it affects your answers, your signs. So 2 times 3x is 6x plus 4. Plus 2 times 2 is 4x minus 2 times 1 is 2. So that will give you 10x. 6 plus 4 is 10. 4 minus 2 is still plus 2. Okay. All right, here's also in terms of x questions. Write down the area and the perimeter in terms of x of the given figures below. I think I have dealt with this in a previous exam where I've done the memo for the exam in a previous lesson or video, but I'm just going to quickly do that again. The area will be 2x times 2x of a square, so it's side by side. That would also be 2x, which gives you 4x squared. The perimeter, 2x times 4, which gives you 8x. The area over here, length times breadth, which is 2x times x, which gives you 2x squared. And the perimeter is 2x plus 2x is 4x, and x plus x is 2x, which gives you 6x. The area of a circle is pi x squared, and the perimeter is 2 times pi times x. You could have simplified that 2 times pi and then write it as pi times 2. So you could have written it as well as 6.28x as well. Okay, question 6. Study the figure below. Prove that triangle AED and triangle BFC are right-angled triangles. So again, if you look here, I can immediately see this is Pythagorean triplets. 8 squared plus 6 squared should give me 10 squared, which is there 10 as well. So 6 and 8 and 10 is I'm just going to go quickly because I have done this in a previous video. Determine the surface area I've done the cylinder. I'm just going to skip through. Again, yeah, in terms of x, a school nursery playground is in the form of a rectangle with the length 1 meter longer than the breadth. They want to enlarge the playground by adding another 2 meters to the length and 3 meters to the breadth. Determine the difference in area of the new playground to the old playground. It's almost similar to the other one that we had with the sand pit. So I'm going to let you do that one by yourself. I'm going to quickly show you the answer. I say exactly the same as the sand pit. You can see sometimes the teachers uses questions over again and then they change just the wording a little bit. Okay, let's look at our last question for this video. Calculate the radius of the following quarter circle if the perimeter of this shape is equal to 86 centimeters. So we know now this is a quarter circle which we can see like that. But if you've got a circle, the perimeter, sorry, just want to quickly do this. If you've got a circumference of a circle, we know that it's pi, 2 pi radius, 2 times pi times radius. But now, if we divide it by 4 to get this quarter circle, can you see that you'll only be left with this arch? So I'm going to do that with this picture that I've just drawn here. So if I divide it by 4, sorry, now I have to go back all the way. Can you see that I am only left with this arch over there? So your formula is 2 pi r divided by 4 gives you only this arch. And now how do I get the full picture as shown here? I need to add 2 radii. Okay, so that tells me 2 pi r divided by 4 plus 2 radius gives me 86 centimeters. Okay, so now we want to chip away at this. We want to follow up on our algebra. We're going to use our algebra to get the radius. Okay, so first of all, I don't like this divided by 4. So I'm going to times by 4 all throughout, all my terms times by 4. And then I'm left with 2 pi radius plus 2 times 4 is 8r is equal to 344. Okay, now I'm going to factorize, take out an r, and what am I left with? 2 pi plus 8, which gives you 344, because we want to get the radius alone. And now we're going to divide with 2 pi plus 8. Remember, that's just a value. Pi is just a value. 2 times pi plus 8. Okay, so 344 divided by bracket 2 times pi plus 8. I just want to see, I must rather do this in steps. Let's rather work out the answer over here. We can rather just keep a few decimals. So 2 pi plus 8, if I put that in my calculator, 2 times pi plus 8 gives you 14.283185, which will get rid of all of that. But what I do on the one side, I need to go and do on the other side. So 344 divided by 14.283185 gives me the radius rounded off is 24 centimeters. So now, because you want to double check that your answer is correct, let's go put it back into our original formula. 2 pi 24 divided by 4 plus 2 times 24. And if you put that in your calculator, let's see whether we get 86 centimeters. Yes, and it gives you answer very close. Maybe because of all the digits, it gives you 85.699. Okay, so it's very, very close. So your answer is correct. All right. I hope this helped. Sorry, it is so hot in my class. It is like we're going through an extreme heat wave. So I feel sometimes I'm rushing. But yeah, I hope you enjoyed this video. And I hope it all goes well with your exams. If you are finished with exams, oh, you are lucky. For my students writing in 2 days' time, I really, really hope that you do very well. You are almost finished. And then I always say, make the holiday worth it. So that, you know, you work hard now so that you can rest very well during the holiday. Thank you so much for watching and all the best. Bye.